Good morning. All right, day 3 of exponential growth and decay, and I got some notes for you. They're going to be very helpful for the rest of this week and the rest of this unit. So feel free to pause me when necessary. I will get to this in a minute. These are two different questions that we're going to work on together. This first thing up here says to remember when doing a change, exponential growth or decay, you're always given a percent. Always change that percent to a decimal. So remember to always change the percent to a decimal, then add the decimal to 1 for growth, and subtract the decimal from 1 for decay. In these word questions you're going to see for a while, you got to know what certain words infer. So keywords for growth are appreciate, increase, grows, earns, occurs, Q or whatever. I'm just waking up. Keywords for decay. You got depreciate, you got lose, you got half-life, you got shrinking. So those are some keywords that let you know this is a depreciation question or this is a growth question, because if you're adding one to a decay situation, you're going to get a vastly different answer than subtracting one. So let me show you what this means. These are the rules you're always going to follow. I'm going to do 2 different questions. I wrote them up here. I'm going to pause this, write some more questions up for you, do a couple of different examples. So first things first. Mike deposits $200 into an account, and every year it earns him 12%. How much is the account worth in 6 years? So we know earning is a growth. So I know I'm going to take this percent, which is 12%. I'm going to change this because I want to do 2 different things. I'm going to change this in just a minute. But 12% as a decimal is 0.12. And that is my initial value starting point. Remember, we're always going to use the same equation, a times b to the power of x, initial value, growth or decay factor. And as we move forward, let's build the equation. So y equals, initial value is 200. My growth factors, I add 1 to this now. 0.12 plus 1 is going to be 1.12 to the power of, well, I want to know how many years, so instead of x, it's going to be 6. And I need my phone, perfect. And let's see what this comes out to. So when doing this, we just use our trusty little calculator. We're going to do 1.12 to the power of 6. And I get some messy decimal. I multiply that by 200. And I'm going to have, after a $200 investment, after 6 years, this account will be worth approximately $394.76. So some questions might ask you, how much money did you earn? So how much is the account worth? How much is in the account is $394.76. How much did you earn or make? Well, you made the difference of $394.76 minus 200, so you made $194.76. So that's that question. My next question, I recognized something and I wanted to make a change in the middle as I was reading this, because I know that you guys tend to make basic mistakes when changing percents to decimals. So I chose this to be 9% instead of 12%, okay? So this question says the population of an apartment building is 4,000 people. Every month the population goes down. Maybe I add another word to this word bank over here. Goes down. All right, just so you don't forget this. Goes down. Every month the population goes down by 9%. How many people remain after 1 year? All right, now I got 2 different things here. First things first, let's change this percent to a decimal. And you guys got to know that 9% as a decimal is equal to 0.09, not 0.9. 0.9 is 90%, 0.09 is 9%. Think about dollars and cents, okay? Help you out with that one. That's crucial, okay? The next thing is, I got to subtract 1 minus this, okay? So this is what you always do. You take 1 minus 0.09, and you're going to get 0.91. So that means, if you think about it, if you're losing 9% per year, that means you have left over 91% of the people that were there before. So that makes sense. But if you do 0.09 minus 1, you're going to get negative 0.91. And this should never be a negative number. Okay? So now let's start building our equation to make sense of this. So this is y equals, my initial value was, how many people? 4,000. 4,000 people. My decay factor is 0.91. Now I did this on purpose. You got to look carefully. I said every month the population goes down by 9%. My question was, how many people remain after 1 year? You got to know to convert that 1 year to 12 months. That's crucial, or else you're going to make a big mistake. And I'm going to be throwing a lot of questions at you guys like this, so be ready for it. So now that we know that, my next thing is 0.91 to the power of 12. That equals a messy number times 4,000. We lost a lot of people. I wonder what's going on at this complex. That means we're left over with 1,200, and roughly these are people. We're going to say we can't round up for people, so we're going to keep it at 89. That's good enough. Okay, you never round out for eliminating people. Well, in this case, you know what? I'm sorry. You can't because it's close enough. It's actually 0.9 back here, so we'll just say 90. Okay, approximately 1,290 people. Okay, you never want to put decimals for people. You just run around up or round down for a whole number. Make sense of that. I'm going to come back with 2 more questions, and we'll wrap it up with that. Okay, so here's my last 2 examples for you guys. Another growth and decay example for you guys. So the first question says the Cubs signed a player for $4 million. Every year his salary goes up by 3%. I want to know how much he's making after 5 years. So first things first, change that percent to a decimal. I cannot stress this enough with these single-digit percents that it's always 0.03. And I'm plussing 1, so I know my growth factor is 1.03. Now I'm going to make my equation y equals initial value of $4 million, okay, times 1.03 to the power of how many years? 5 years. Okay, so let's do our work. And I'm going to do 1.03 to the power of 5 equals that number. Take that exact decimal answer, multiply it by 4 million. And I get an answer of what did I do wrong? Hold on, my calculator's messed up. Hold on a second, guys. Alright, so I know my mistake. I pressed 1 extra 0, so my calculator thought I was typing in 400 million, not 4 million. Or 2 extra zeros. So I got the answer of approximately y equals 4,637,096, give or take. That's good enough. That's how you do that one. My next and last example is a decay situation. Remember, we just add 1 for growth, subtract the percent from 1 for decay. So here goes. Mr. Lee bought a car for $15,000. Every year it depreciates, keyword depreciates, in value by 7%. How much is it worth after 4 years? So let's make the equation. First thing, I'm not making the equation, let's do this. So 7% as a decimal is 0.07. 1 minus 0.07. The way I do this in my head, so for like quick mental math, I just do 100 minus 7, and I get 93, or in this sense, 0.93. Okay? Trick will always work. So my equation is y equals 15,000 times, parentheses, 0.93 to the power of 4 to represent the 4 years. So let's get our calculators out. Let's do our work again. 0.93 to the power of 4 equals some weird decimal times 15,000. And I get an answer of 11,000. $11,220 estimated. Okay? I will see you all in class. Thank you.